So yeah, I was talking about NumPy. Let me know like where did I lost my voice?
I guess, let's see. I think it was, can you scroll up a little bit more?
Here.
Yeah, I think after the mathematical fast option, tools for reading, writing array to disk. After the disk writing, that's the part where I didn't hear you
Oh,
anymore.
disk writing. After that, memory mapping. Yeah, we're gonna talk about like in a while about this point. This is important, but that's really talking about how the NumPy arrays are stored in disk or how they're mapped into the memory or that stuff, and that's not really important. But yeah, the important part was like yeah, we can read and write that stuff into our local disk drive. But if you notice this list, we can't really save this list to our local disk. We can do something like store this in a text file, but obviously we need to apply a for loop and do something like this, make a string and then 1 2 3 4 5, and then when we are reading this thing, we again need to loop through this stuff and remove these commas and convert that into a list. But in NumPy we have some functions like np.save. We can pass the file name and then the array a2.
Yeah.
This is a2 array, and if you could see, like, we have a file here, new.npy, that stores our NumPy array. So yeah, that's
Mhm.
what we're talking right there. We can really store, read and write the array from the local disk. And yeah, next point was linear algebra, random number generation. Yeah, as you know, we have a random kind of numpy.random. We can generate like normal distribution and Gaussian distribution and that kind of stuff. We can do linear algebra, that stuff. And the next point was a C API for connecting NumPy with library written in C, C++, and that stuff. So the thing is, there is a C API. API is nothing but just a bridge between C language and Python that makes this NumPy work on the Python stuff. In short, like, this NumPy was written on C, and the thing which connects the C language and the Python is this like C API. This is just a bridge, nothing else, nothing, even not like nothing important here. But the important thing to remember is like NumPy is written in C, C++, or Fortran. These are like the best languages in terms of efficiency and performance and that stuff. So yep, that's why NumPy arrays are fast, because yeah, they're written in the best language and they're connected with this API, and that's it. And what's next? Choice for wrapping legacy code and then just leave it. While NumPy by itself does not provide modeling or scientific functionality, having an understanding of NumPy array and array will help you use the tool. Okay. Pandas much for efficient. Okay, just leave that. Yeah, for data analysis application, the main area of functionality I'll focus on. Okay, that's what they're talking about. Fast vectorized array operation. What they really mean by that, we already discussed that stuff. Like, we were trying to multiply a list by 3, and that
Yeah.
was giving us something like that, and that's what they really mean by here. Fast vectorized array operation. They're like, you don't need to apply
Yeah.
a loop
Yeah.
and just multiply or do any kind
Like
of mathematical.
multiplying vectors and matrices, kind of. Yeah.
Exactly. Matrices, because yeah, NumPy supports multi-dimensionality. So yeah,
Yeah.
that's what they really mean. Okay, transform and that kind of computation. Okay, yeah, we're good. Common array algorithms like sorting, unique, and you know some other like finding NaNs and filling
Mm.
NaNs and that stuff. So we have some kind of array algorithms or something like that. Efficient descriptive analysis, aggregation and summing, summarizing. So yeah, we could, let's suppose we have a data set and we wanna group up the data based upon the gender. So it will group up whole of the data based upon one column. Inside that column, we were having two features. One was men and one was women. So now if we applied that kind of stuff, we could aggregate or summarize the data of women's and men's separately, like mean, max, median, and that stuff of women's and men's kind of separately. That's what they really mean. We have a group.groupby function in Python. In that we could aggregate and then calculate the mean or the sum or any kind of stats of that particular part of the data. Data alignment and relational data manipulation for merging, joining together heterogeneous data and that stuff. So yeah, no, that's yeah, like I guess we know about that. You can merge that out if that's
Yeah, that's fine.
heterogeneous means of different data types. uh, we don't have any restriction that we can only store numbers or strings or that stuff. We can mix and match strings and that stuff. Like what they really mean by that stuff is we can have column that have different data types, but obviously in a single column we can only have single data type. Like if there is a column of price, it should be of numbers or float. But if there is a column of maybe what could be say like house quality, good, bad, or just normal or average, that should be obviously of string data type or object data type. And we could merge the data or join the data, heterogeneous data, like columns of different data types. That's what they really mean. Expressing conditional logic, as we will see in a while, what they really mean is like if I go here and if I do A2, go in A2 and tell me where I can find number greater than 1 or maybe a number greater than 2. If I'll run this, that's something logical. So it's like on this index the condition is false, on this index the condition is false, but for these two indexes this particular condition is true. It's like if I take this number, oh yeah, it's smaller than 2, so it's false. 2 is smaller greater than 2, no it's not, it's like equal, so this is also false. But 3 and 4 are greater than 2, so right here I have this kind of stuff. So that's what they're talking about.
Okay.
Conditional logics on array. Yeah, instead of looping with an if else, like see, we don't really need to put an if else if the number
Yeah,
is
yeah.
greater than and that stuff. We just do that stuff, and that's also one point that makes us more
NumPy. Yeah.
productive. Yeah, and obviously it's fast. The calculation itself is fast. Yeah, group wise data manipulation. Yeah, we discussed about that. Aggregation, transforming, function application, like apply a custom function on that stuff. I'm like, if the value is greater than 2, then go and do this stuff. Maybe take mean and do like blah blah, or maybe drop that thing or different kind of things. Okay, I hope like these points are clear. Like nothing special here,
Yeah,
but
yeah, yeah.
we should be,
Yeah,
we should know this stuff that we can.
yeah,
That's what
yeah.
what's NumPy built for. While NumPy provides a computational foundation for journal numerical data processing, many readers will want to use pandas at the basic of most kind of statistics, or just leave this. No, we are just talking about NumPy. Okay, what's here? There are a number of reasons for this. For what? NumPy is so important for numerical computation in Python is because it is designed for efficiency on large array of data. So yeah, that's one of the reasons why we use NumPy and pandas for data science and deep learning, because we have huge data sets. And to do calculation on them, we don't want to spend much of the time on designing loops and waiting for the result of those loops. Store data in a contiguous block of memory. So by this sentence, contiguous block of memory, what they really mean is, let me create a new thing. Why is this thing? Okay, let's create a memory thing. Okay, let's suppose this is our RAM. Okay, yeah, that's our RAM. And inside our RAM, we are maybe having some portions. Let's divide that. RAM is divided into, maybe the portion is too small. Let's suppose this kind of stuff. RAM is not really divided into portions, but just for sake of understanding, I'm doing that. Okay, that's done. Let's suppose at this place I have stored my movies, and at this place, maybe my, what could we say, my, I don't know, different data stored on different places, something like that, scattered on RAM, something like that. Different data on different places. This is like a big file. I have whole lecturers of my university stuff, and right somewhere there I have that stuff, and just random data, like I'm just doing that random data stuff, filling up the RAM. That's it, and that's it. And let me just split that. Oh, black color. So yeah, I guess I'm done here, and now I need one more here. Yeah, I guess that's good. And let's suppose I was having a list, that is, list is equals to, that's something like this, that's like 1 2 3 4 5 6 7 8, and that's like this. In case of this list, what Python will do, Python is like, let me make a copy of this thing and yeah, place it here. So what Python will do, Python will just come here. Let's choose a light color. Python will come here, keep on scanning the stuff, like it will go scan this stuff. It's like, oh, this stuff is filled, but it's like, oh, I found an empty space. So what it will really do is it's like, okay, it analyzes the empty space and picks up a portion of the list and tries to store that like in between that space.
Okay.
Yeah, and after that it like keeps on scanning, and it's like, oh, I again found some space, and it's like trying to store the data like there, which it can be stored, like the maximum data it can store in that portion, and it keeps on scanning like that. I don't know, like scans that like that. It's like, oh, I found a small portion, and again will store something from that list, and yeah, it will keep going like that. So that's how the data of list is stored in our RAM or memory. It's not contiguous. Contiguous means it's scattered away. Not contiguous means that something is like it's grouped up, it's stored at one place, or like in a continuous manner or something. It's not breaking. But this list, it's stored in something like this, and how, okay, this is stored, and next time if I need that again, what makes that like easy, like it has some index or something. It's like my next part is on number, let me number these things. It's like 1 and 2 and 3, 4 and maybe 5 and 6 and 7. So this part is telling, oh, next part is on number 3, and this is telling my next part is on number 5, and this is telling my next part is on index 6 basically. So whenever next time I'm like, oh, I need this list, Python will go inside this RAM and it will start scanning. Obviously it knows where's the first item. It will go here, pick up this thing, and this thing will tell, oh, next thing is on index 3. So it will jump to index 3, pick up this thing, and then it's like, oh, I need to go on index 5. It will go here, pick up this thing, and go here and pick up this thing. That's what make it like a bit slow, because it's scanning and picking up, like gathering the data of the list and that stuff. But if I talk about NumPy array, it doesn't stores like that in our memory. It's stored in a contiguous way. NumPy array, and let's suppose I have an array that's same like that, something like that. Oh, maybe we can do up to 7 8 7 and 8, and if I close that, okay, we are good to go. What Python will do, Python knows that this is a NumPy array and I need to find a good space where I can store whole of this data at a single kind of place. So what it does, it enters the memory and will try to find a space where whole of this thing could fit. It will, keep on scanning, and at this point it's like, oh, I found a good space, and it will, simply store this thing in the RAM. And next time when we are like, oh, I need this thing, Python will know, oh, I need to go here and pick up this thing which is on number 7. I need to go on index 7 or somewhere, like the address of the memory at where this array is stored, and it will simply go there and pick up and make us available for the calculation. So that's what they really mean by contiguous block of memory, is stored in a contiguous block of memory where all of the data set is like present. It just goes there, picks up, and makes that available for us. Hope this kind of part is clear, like how list is stored and how okay, that's great. So yeah, independent of other built-in Python objects, it doesn't really depend on anything. It has its own way of storing itself in the memory. NumPy library of algorithm written in C language can operate on this memory without any type of checking, or just leave it. NumPy array also uses much less memory than built-in Python sequences. So yep, I don't know why that uses, probably because it's written in C. That's what makes it more memory efficient. But the other things like NumPy list and dictionary, those are written in Python, purely Python, and that's maybe causing it. We are adding a layer of Python and then again a layer of machine code, or again operating system and that stuff. So that's what's making it more kind of huge stuff. Not really huge, but if compared to NumPy array, like if I compare that same list, something like this, if this is stored in list, it could have maybe, let's suppose, 1 KB, maybe 10 KB, and if this is in NumPy, maybe it could be maybe 2 KB or something like that. So that's what they really mean by that stuff. NumPy operation perform complex computation on entire array without need of any loop. Yeah, we already know about this stuff. So yeah, that was a quick kind of intro towards NumPy. And yeah, now we're coming towards the code part, and here we go, like I guess somewhere here, code part. Okay, yeah, we added that stuff. So importing NumPy, you can just import that by something like this, as np. That's like a convention to import it as np. It's just a shortcut, like as, and we just specify the shortcut. So let's try to do that in our code. Oh, let's just follow this, or maybe we could go here and do that stuff. Condition. No, we are doing like some advanced thing. Can you hear me?
Yeah, sure, I can hear you.
Okay, that's great. Let's jump to this algorithm. Then, oh yeah, that's a good point. NumPy based algorithms are generally 10 to 100 times faster than pure Python counterparts used significant less memory, that stuff. So yeah, it's like NumPy operations or calculations are 10 to 100 times faster. And then again, n-dimensional arrays, we can store an array inside an array, and then again inside and inside and inside. That's what makes it n-dimensional. And yeah, here we have a quick example of how we can generate a random NumPy array. We are like using np.random.randn, like random in numbers or something like that. I'm like, give me 2 rows and 3 columns, and that's what exactly it's doing. It's populating 2 rows with 3 columns, and that's one of the way to generate that stuff. Like, it's just a start. So I don't know if you could do that. Let's try to do that. This notebook already has some code, but I don't know, maybe we can make a new one. 2.ipynb and take a fresh start. Import NumPy as np. And after that we could just copy this because there's nothing kind of hard here, and just like do that. Let's wait for the kernel to connect. Oh yeah, it's connected. So yeah, it populates like a array, two-dimensional array. But just a quick example of the arithmetic operations, we could just do that. We already saw the example, but let's just do that again. Data multiplied by 10, and if you see it was 0.3, now we're having 3 point something. So yeah, quick arithmetic operations, and that's pretty much of it. That was like just a quick start of NumPy. But yeah, here we have something important. Standard NumPy convention, import NumPy as NP. So yeah, something like that. Yeah, next thing is we could check the data types and the shape of the NumPy array. So let's do that here. I'm like data.shape to check the shape of my array. It's having 2 rows and 3 columns. And if I want to check the data type, it's like d type. Okay, it's the data type is float 64. Yeah, exactly. ndarray in the next chapter refer to something. Okay, just leave. Array function accepts any sequence like object. Okay, yeah. If you want to convert, if you already have a sequence of NumPy, maybe it could be a tuple, a list, or yeah, tuple or list or set or something. We can pass that into this function NumPy array. Like this is a function, and inside that we can pass that list. Here we are just passing this list, and that got converted into NumPy array. So yeah, after that we can do some calculation or something like that. And here we have an example of two-dimensional array. We were having a list, and inside that list we were having 2 values, and both values were again 2 lists, and again inside those lists we were having a couple of values. So yeah, two-dimensional list, and we then converted that list by using numpy.array function to convert that into NumPy array, and yeah, it got converted. So yeah, a quick one more thing, how to check the dimensions. We can check that by ndim method. It's saying your this array has 2-dimensional, or like it's 2D array, or yeah, 2-dimensional array. That's what they're referring to. And infer a good data type for the data that is created. And yeah, we already checked the d type. And what they're really telling here is NumPy is kind of really smart. When you store anything inside that, it tries to match or come up with the best data type for that particular array. We have a couple of data types. If I talk about that, we are having, let's create data markdown. We have data type that's like float, maybe 16, and up till float maybe 256, and same for like integer. Integer starts from 8, or probably 8, maybe 4, but as far as I remember, it starts from 8 and up till like 256. So yeah, Python figure out what's the data that you're giving to this function, and it tries to come up with the best data type. In this case, obviously it's like an float thing, decimal. So yeah, it's like, okay, I'm gonna make the type of this array to float 64, but you can really change that. We're gonna see that later, but that's what they were saying here. Infer a good data type, and that's it. NumPy number of other function for creating new arrays, as example 0s and 1, create array of 0s and 1 respectively. Okay, yeah, we have function to create an array filled with zeros. It's like numpy.zeros. We're just passing the length or the shape. We're like, just give me 10 columns, and yeah, that's it. An array of zeros. And here if I use like, I can specify the shape inside a tuple that I need 3 rows and 6 columns filled with zeros. NumPy is at dot zeros. So yeah, we get an array like that. Dot empty. this thing is a bit tricky. Like right here, you would see the all of them are filled with 0. But if I will run that in VS Code, I'll not get zeros. I'll get something else. Most probably something else. If I store that in A1 and again I print that A1, you will see that it has some random kind of value. Somewhere it's 1 and blah blah blah. What's happening here? That's this numpy.empty function. It does not generates any kind of number. What it does is it kind of goes into the RAM, and obviously computer works in like computer understands or stores the everything in binary form, 0 and 1s, and on that particular place where I said it to create an empty array of this shape, it went there, and at that place we were already having some junk or trash data or cache, and this function utilized that garbage data and said, okay, I'm gonna just use that data and place that here instead of generating 0, using the computation and generating 0 and again replacing that junk data with 0. What it does, it's like a bit efficient because we already said it to create something empty, so we are not really caring about what's stored in that stuff. So it's just using the junk data present at that space where the numpy array is getting stored. So yeah, but if you will restart the kernel, or I don't know, maybe restart the computer, then maybe you could get 000 everywhere because there is no junk inside your RAM or memory. And yeah, it's not safe to assume that numpy.empty will return an array of all zeros. In some case, it may return uninitialized garbage values. So yep, that's what they really mean. But if I give you an example, let's suppose I was having a new hard disk. I stored movies and all of my disks got full, and I deleted, maybe I'm like I want to delete like this and this file from my hard disk. When I will press delete key, like in my hard disk, those files will still exist, but my operating system will forget where what data was stored, and right here I'll not see anything. But that's why we have some tools like data recovery tools and those stuff. They just go and scan the hard disk to recover the data because it's already there, but our operating system just forgot about where everything is stored. But your question should be like, if the data is already there, then how can we store the new data? Well, the thing is, when we will try to store anything new on that particular place, our system will be like, okay, replace that old data with this new data, and also this time remember what is stored at that place. So that's happening same in this case. It's just utilizing that old data in that garbage data in that memory space or something like that. Okay, I hope this is not like
Yeah, I mean,
something hard.
this
It's
is
just yeah,
well
just
understood.
talking
And
about
I'm
stuff.
going back to rewatch the videos again, so no problem.
Yeah, so here we go. Array creating functions. We have all these functions to create some arrays. You already know about numpy.array. As array is a function. Like, do you remember what as array does?
You'll be able to already. Yeah, I mean,
Like, any guess? By the way, can you hear me?
I can hear you. I'm thinking.
Oh, okay, yeah.
Yeah, it
This
apparently
data.
says convert to ndarray.
Yeah.
But do not copy
Yeah.
if the input is already.
What that really mean by that sentence is, let's start from a bit scratch as array. What that really mean? I can use this numpy.asArray function, and inside that I can pass this previous array, a1 array. I can really pass that inside that stuff. And let's try to store that into b2 is equals to something like that. And when I print b2, I'll get a copy of that stuff. And what they said, but do not copy if the input is already an nd array. At this point, it will not create an copy of a2, but this will be just a reflection of a2. If in b2 I'm like go on position 0 and then again go on position 1 and set that value to 99, and if I check for a2, probably a1. Oh, where is that stored? Go in 1. Oh, I guess I need to first. Well, let's do b2. Maybe I'm wrong, maybe I'm right. Where is that stored? Oh my god, let's do this. Yeah. Oh, so that's where it got stored. Oh yeah, that's where it got stored. Yeah, that's where it got stored. Like if you see here, even in A1 it's 99 something, and even in B2 it's 99 that stuff. So that's what they want to explain, that if you will pass an array inside this function, it will not create a copy. It would be just a reflection. But if you will pass an list or something like that, then for sure we'll create a new NumPy array or something like that. It's I don't know where it is, like we don't really use this as array, but in some cases if you want to make a copy of an array, we can simply do is like c1 is equals to a1 dot copy. We could just create a copy of that array and that would work really great. But I don't know like where that really needs to be used. But anyways, a range is just generating, range of NumPy arrays, numpy.a range, and I'm like generate array up till, not exactly up till 10, but 1 less than 10, because index is starting from 0. So yeah, that's the function. 1 is for creating array of 1, as we already saw. We could be just like numpy.1 ones, and again shape is 10, but I'm like I want to create array of ones, but the shape of that array should be like this c1. So I'm gonna pass c1 inside this function, which is called ones underscore like something like that. So I'll get the array filled with 1, but the shape of that array would be exactly like this thing. So yeah, 1 like, 0 and 0 like are same exactly like that. Empty, we already saw that. Empty underscore like is already like that. Full is something like, do you remember what full was for? Full or fill? Full was to, yeah, basically create an array. I don't know. Oh, let's see what parameter it takes. Shape, fill value. Yeah, first is shape, and then I'm gonna tell for what values I want to fill that for. I'm like, okay, fill that with 10. So I'm gonna have 5 values and they are like exactly 10. So like if you want a custom kind of fill something like that, yeah, I could specify shape maybe.
Yeah. And I guess that even if you can't remember the meanings of this thing, if you try to use them, then it outputs whatever. Can you hear me?
Yeah, sorry, can you ask the question again?
Well, I said, I guess even if one cannot remember the functions off of the top of one's head, if you try to use them, then it outputs whatever the meaning, whatever output you get reminds you of the meaning of the function.
Oh yeah, you're talking about this,
Yeah.
like these stuffs. Like yeah, we are getting zeros, and that means meaning of
so that
yeah,
tells you what the function does. Yeah.
Yeah, exactly. Yep.
Yeah.
Yeah, full is like, it should be fill actually, but it's full. Yeah, full
Yeah,
array
but
of
I see
this.
when you hover your mouse over it, it gives you a quick description of what it means, right?
Yeah, yeah, exactly right here.
Shape,
Return a new array of, yeah,
integer, or sequence.
filled with this thing. We can also specify the data types, order, I don't know, a lot of things. They even have an example. Fill 2 by 2 by
Uh,
np.infinity. Okay. Full width 2 by 2 and something like this. So yeah, different kind of things. But sometimes we do need, yeah, sometimes we do need, when we are working with, as we were working with binary classification, like parasited or,
yeah, or
non-parasited.
unparasitic. Yeah.
We could just generate, we are like, oh, our data set is of length maybe 10,000, so we need to have 10,000 labels, and we know first 500 pictures are first 5,000 pictures are of like,
Unparasitic.
yeah, so we could just do like numpy dot maybe zeros and say, okay, create 10,000 values, and after that we could put a slice or something. Let's kind of do that. Maybe a1 is equals to something like that. Numpy dot, come on, what's wrong? Oh, double equal numpy dot zeros, and I'm passing in 10, 100,000 and 10,000. Okay, I did that stuff, and now I'm like, from 5,000 up till end, change the value to 1, because last 500 are, non-parasited or
Yeah,
something. So
parasitic.
now
Yeah.
I get an array that's, something like this. First 500 are 0 and that, so I created labels. So sometimes, yeah, ones and zeros are useful. So yep, that's pretty. I and identity, like, do you remember anything?
Oh, we didn't get to this part.
I is like creating a diagonal matrix or something like that. Diagonal, it's a square
Yeah,
matrix.
diagonal
Yeah,
matrix. Yeah, square matrix. Yes.
square matrix, but the diagonal, the line passing from the center, that values are different from the rest of them. Probably, mostly it's filled with 1 or zeros. Oh, how can I fill that with? Okay, n m. Oh,
So
give me these.
are we converting a list to a matrix
Not
with this
exactly in
function?
this I function.
Yeah, or what does it do?
It's just creating a square matrix. I said 2, so it means 2 rows and 2 columns, and that's what it is doing. It generated like a matrix filled with zeros. Then on the diagonal part, diagonal is like the line starting from paint. Let me show you what they really mean by diagonal. This is the square, probably maybe this big one or this small one, and what they really mean by diagonal is like a line from this corner to this, and from this corner to this, and from this corner to this, and on like rest of the places we could have different kind of values, like one value is right
Yeah.
here, one is right here, right, and the
But
center one
every
is,
value on that is the same,
yeah.
right? Okay.
This every value is different, and but only and only the value on these lines are different. Like if you
It's
see
different.
here, this and this is different, but if I increase the size of this thing, you will clearly, oh, maybe this is too much.
See all the one in the middle.
Yeah,
Yeah, yeah,
like a
yeah.